Hello everyone, today we are going to discuss production of X-rays. The X-rays are produced when a fast moving electron strike or collide on a suitable target material which having the high atomic weight, high melting point and high thermal conductivity. There are two types of X-rays too. One is the gas field, that is the discharge tube, or that is called as the Roentgen X-ray tube. So in Roentgen X-ray tube, anode is connected in this way and cathode is connected in this way. Both this anode and cathode are connected to the high potential difference, and here is the reducing the pressure in the order of 0.001 mm of mercury. At that time, the reducing the pressure, there is the stream of electrons are accelerated toward the anode and they will collide on an anode material with a high kinetic energy, high accelerating, and due to the collision, the X-rays are emitted in a random direction. So these X-rays are emitting in random direction. That's why if we want the photograph of fracture bone or bone, so at that time it requires more time because this radiation are moving in random direction. If this radiation are moving particular direction, we will get the quick photo. That's why these colleagues modified this tube, and that modified Coolidge tube is also called as hot filament tube. So this modern Coolidge tube or hot filament tube here is connecting the high tension battery to this cathode and anode. This is the cathode, which is called as filament F, and this is the target material, which is made up of the copper, and this is called as the anode. So this modern Coolidge tube consisting of high evacuated vacuum glass bulb containing anode and cathode. This anode and cathode. So this anode is made up of copper, which having the high thermal conductivity, and when this filament get heated due to the low tension battery, and the current passing through this filament is controlled by using this rheostat. So once we have passing the more current, this filament get more heated, and due to the heating it emit the electrons, and due to the heating it emit the electrons, and this cathode filament get heated and stream of electron are emitted. This process is called as thermic emission. So due to the heating it emit the electrons, and due to the high potential applied, these electrons are accelerated toward the target material and they will collide on a target material. So most of the kinetic energy they give to in the form of heat, and that heat is cooled. This target material is cooled by circulating the cold water through this evacuated hollow anode, and some part of kinetic energy produce the X-rays. Some part of kinetic energy is utilized to produce the X-rays in certain direction, and that's why we will get the quick photograph. The cathode, tungsten filament. The target anode consisting of copper block in which a piece of tungsten or molybdenum is fitted by making angle 45. So in the front of this anode there is situated the piece of tungsten or molybdenum which having the high melting point, because these electrons are moving with accelerating toward the target and they will creating very high heat. So more temperature is created here. That's why the high melting material, that is tungsten and molybdenum, is connected in the front of anode, and here making the angle 45 to the stream of electrons. That's why the X-ray, whatever the X-ray produce, they will moving in certain direction. The target anode having a high atomic weight, and due to high atomic weight reduce the hard X-ray, which having the high melting point, high thermal conductivity, so it can easily carry out the generated heat. So the target material which having the high thermal conductivity, that's why it can carry out the generated heat. Due to the bombarding high energetic electron on target, the target generate heat. So on the target there is generating the heat, and this heat can be carried away by flowing cold water into a hollow tube attached with a target anode. A high AC potential of about 20,000 volt is applied between cathode and anode. Due to the high potential applied across the cathode and anode, that's why these electrons are accelerated towards the anode with a high kinetic energy. Due to this high potential difference between cathode and anode, the stream of electron emitted and get accelerated toward the target. So they get accelerated toward the target and strike the target. This accelerated electrons give the kinetic energy to the target. So this accelerated electron give the kinetic energy to the anode, and most of the kinetic energies pass in the form of heat, and that is cold. This anode is cooled by using cold water circulation, and small amount of kinetic energy is produced to generate the X-rays. And most of the kinetic energy of electron are dissipated in the form of heat, that is heated by anode, and only small amount of kinetic energy is converted to produce the X-rays. The heated target is saved. Here what will happen? The electron are accelerated with high kinetic energy. They will bombard on a target anode, and that anode is saved by continuously circulating a cold water. If we have not circulating the cold water, the target material there is producing some defect on a target material if we are not passing the cold water. The intensity of X-ray depends upon the number of electrons striking to the target anode. If the more electrons are striking on the target anode, so there is the more intensity of X-ray is produced. So rate of harmonic emission from a cathode filament, if the more electrons are emitting, they will collide on the target, so more intensity we will get. So that intensity we can control by using the low tension battery. There we have connected the rheostat. By rheostat we can control the current of the filament. So here by using rheostat we can vary the resistance, and with the varying resistance the current may be changes, and we can control the X-rays intensity. If we apply more potential difference across cathode and anode, then there is the higher is the speed of striking of electrons. If we apply the more potential difference across cathode and anode, so that electron are moving, higher is the speed of striking electron, that electron are moving high accelerating, and that bombard on a target material, and so it produces the more penetrating power X-ray. So there is creating the more penetrating power of the X-rays, and that more penetrating power X-ray is called as the hard X-ray. If we have applied the small voltage potential difference across the anode and cathode, while low penetrating power of X-rays are termed as a soft X-ray. So we have applied the more potential difference, so hard X-ray we will produce, which having the more penetrating power. If we apply the less potential difference across the anode and cathode, we will get the less penetrating power X-rays, that is called as soft X-rays. This high and low penetrating power or quality of X-ray controlled by changing the potential difference among the cathode and anode. We require the high penetrating power X-rays, so more potential difference we want to apply. If we want a low penetrating power X-ray, soft X-ray, so we want to apply less potential difference across cathode and anode. Thank you for watching this video till to end. If you like this video, please like, comment and share with your friend. Thank you for watching this video till to end.